Good morning, everyone. So, today we are going to start a new chapter where we are going to see the power series solutions of a given first order or second order differential equation. The idea here is that for a given differential equation, we may not be able to solve it using the existing methods. In that case, we may require to find the power series solution. So, a power series looks like this one, summation a n x raised to the power n. It is a power series about x is equal to 0, and about any point x naught the power series looks like summation a n x minus x naught raised to the power n. Now this series a n x raised to the power n is said to converge at a point if the limit, you can say either limit n tends to infinity a n x raised to the power n exists. It means that this sum, let's say you write n, so the sum 1 plus 2 plus 3 so on, so this sum of the series is converging to a finite value or to a function. In that case we say it is convergent. Otherwise, if it is not converging, we will say it is divergent. So if it is convergent, then the sum of the series is the value of the limit. Now for the convergence test, there are mainly two methods. One is ratio test and one is root test. I will explain both of them by using the example, mainly the ratio test, which we used very often. So for any series of the form summation un, which is summation a n x minus x naught raised to the power n, so the ratio test says that the limit n tends to infinity. So we need to find the values of x for which limit un plus 1 by un is less than 1. Those value of the x are the values where the given series is convergent. Yes. So for example, this is for mod x minus x naught is less than r. This is what we got. Then r is said to be the radius of convergence, and from here you will get an open interval, which is the interval of the convergence. It would be better clear once we see this example. So let's say we need to find the convergence of, so here my un is n factorial x raised to the power n. So implies from the ratio test limit n tends to infinity n plus 1 factorial x raised to the power n plus 1 divided by n factorial x raised to the power n. This should be less than 1. So I can take x outside and the limit would be, it only remains n plus 1 should be less than 1. Now limit n tends to infinity, it means n plus 1 is going to infinity. So the left hand side term would only be less than 1 when, so this is less than 1 only if your x is 0, otherwise it is not possible, because we are approaching very close to infinity. So if you multiply it by 0, then only we can find that the term would be less than 1, otherwise we cannot guarantee anything. Yes, so in this case we will say the radius of convergence is 0. This is a special case where it is not an interval, otherwise the radius of convergence is always an interval. The second case is limit n tends to infinity x raised to the power n plus 1 by x raised to the power n plus 1 factorial n factorial and less than 1. This gives you again mod x would be out and your limit would be applied to 1 by, so mod x and limit 1 by n plus 1. Now you can see that limit 1 by n plus 1 is 0. It means that whatever value you choose for x, it would always be less than 1. It means it converges for all x, which means the radius of convergence is infinite, or the interval of convergence is minus infinite to infinite. The last case is summation x raised to the power n, so it implies x raised to the power n plus 1 by x raised to the power n, and limit should be less than 1. This simply gives you mod x is less than 1. Yes, so mod x is less than 1, it means it is converges. So it converges when mod x is less than 1. It means that your radius of convergence is 1 and your interval of convergence is -1 to 1. So over this interval only the series x raised to the power n converges, otherwise it diverges. It means if you choose any value which lies from -1 to 1, then it's okay, it is converging, otherwise it is diverging. Yes, so this leads us to the result which says that the series summation a n x raised to the power n converges for mod x is less than r, where r is radius of convergence, and in that case it converges to any function of x or constant. So f of x, which means I can write down f of x is summation a n x raised to the power n. If it happens, then f of x is continuous and has derivatives of all orders, which leads us to compute the value of a n. So for example, you know that you need to find, you have sin x and you write sin x as summation a n x raised to the power n. If you know that sin x converges over a interval and you have to find the value of a n, then a n would be fn0 by n factorial, where it represents the nth derivative. All of these things are covered in math 1 course, so we are not going into a lot of detail. It is just I am touching it and you will see that we don't require it much. So analytic function, if a power series converges to f of x in some neighborhood of x naught, some neighborhood of x naught means in the interval of convergence, then f of x is said to be analytic at x naught. So it simply means that if you have to check f of x is analytic, it means let's say you want to check f of x is analytic at x equal to 0, then you have to see does there exist a power series solution or its power series expansion about x is equal to 0. Yes, and how do we find a n then? So this is representing about x is equal to 0. If you find about x is equal to 1, instead of 0 you write 1 and so on. Okay, so let's try to solve the power series solution of a first order differential equation. Once we do the first order differential equation, then we will move to the second order differential equation. Now first order differential equation, there is no condition. We just assume that if I call it equation 1, then we assume that 1 has a power series solution. In case of second order differential equation, there are certain conditions under which power series solution exists, but in case of first order there is no problem. So 1 has a power series solution of the form summation a n x raised to the power n. Yes, and we assume that it is a power series solution, so which converges for mod x is less than r is greater than 0. Yes, it means that the equation 1 has a solution which is analytic at x is equal to 0. So we are already assuming it because in case of first order differential equation it always exists, so there is not a problem. Now if I have to find the solution, then my y dash would be summation a n x raised to the power n minus 1. Yes, so if I substitute the values of y dash and y, let me hold for a second. So now I have the value of y dash and y, so I will substitute it into the equation 1, that gives me summation a n x raised to the power n minus 1, and here the power is x raised to the power n minus 1. It means summation must start from n is equal to 1 and y is n is equal to 0 to infinity. Yes, now if I want to find a relation between a n, because I do not know how to compute a n, so I want to find a relation between a n and its preceding terms, which is a n minus 1, a n minus 2 and so on, That is called the recurrence relation. So to find this, I have to compare the coefficient of either x raised to the power n or x raised to the power n minus 1. If you see the right hand side, then right hand side is simply a polynomial where the coefficient of all powers of x is 0. It means if I say comparing coefficient of x raised to the power n on both sides, then I will get, so here it is n is the coefficient of x raised to the power n minus 1. It means x raised to the power n means I should take an plus 1 and plus 1 minus an, because in this case it's simply an. In this case an represents the coefficient of x raised to the power n minus 1, which means for the x raised to the power n I need the next term, which is n plus 1 an plus 1. So this gives me an plus 1 is equal to an by n plus 1. Yes, provided n is greater than equal to 0. Now I should try to substitute the values. So if I substitute n is equal to 0, then a1 comes out to be a0, then a2 is a1 by 1 plus 1 2, which is a0 by 2, a3 is a0 by 3 factorial, and so on. It means y is a0 is common and 1 plus x square. Why? How this y is coming? Because you have assumed y is an x raised to the power n. So when you assumed y, so here y is your a0 plus a1x plus a2x square and so on. So you need to substitute the values of a0, a1, a2 which we have computed. It's not possible that we may be able to find a general term. It means when we are finding the values of a2, a3, a4, it is sufficient to find 4 or 5 terms, and then we can leave the answer in this form. This is a very special case where I already know this expansion is y is equal to a0 e raised to the power x. But if I do not know, not a problem. There are some standard elementary functions whose expansion we must remember. Other than that, it is not required. Yes, so this is how we got this. So this is the power series solution of the given differential equation. Let's try one more question. So 1 plus x y dash is equal to py, where p is a constant, and it is given y of 0 is equal to 1. So again, your y is summation a n x raised to the power n, which is a0 plus a1x plus a2x square and so on, which means y dash is n a n x raised to the power n minus 1. Now the given equation is y dash plus xy dash minus py is equal to 0. If you substitute the values, then it is n a n x n minus 1, and in the next case you multiply y dash by x, so it becomes n a n x raised to the power n, and in the last case again a n x raised to the power n is equal to 0. So comparing coefficient of x raised to the power n, you will get, from the first term it is n plus 1 an plus 1 plus n an minus p an is equal to 0, which gives you n plus 1 is p minus n by n plus 1 an. So this is the required recurrence relation. If you forget its name, so this is the recurrence relation when n is greater than equal to 0. Now the same thing works. I have to substitute the values. So if I substitute the values, then a1 comes out to be p minus 0, a2 is a1p minus 1 by 2, which is pp minus 1 by 2 a naught. Similarly, a3 would come out to be, and so on. It means that if you substitute the values, your solution is y naught is a naught plus a1x plus a2x square plus a3x cube and so on. This is what we have assumed. So if you substitute the values, then y would be a naught plus a naught px plus a naught p minus 1 by 2 factorial and so on. Yes. Now it is given that a naught is equal to, sorry, y of 0 is equal to 1. So if you substitute y of 0 is equal to 1, it means at x is equal to 0, y is 1. So if you substitute x is equal to 0, on the right hand side you will have only a naught and the left hand side is 1. This means that your y of x is 1 plus px plus p by p minus 1 by 2 factorial x square and so on, which is the expansion of 1 plus x raised to the power p. Yes, so it's a binomial series, and we know that the binomial series is convergent for mod x is less than 1. Okay, so in the next class we will see how to find the power series solution of second order differential.